Example 9.6 is going to see us find the derivatives of a few inverse trigonometric functions. So here I have just two different ways of representing trigonometric function inverses, either the classical way where I have f inverse or trig functions, you can put an arc in front of it, so arc tangent. But same notation, I'm going to find derivatives involving the arcsecant function and the arctangent function. Let's start with A. If y is defined as the inverse secant of 4x, then I need to differentiate the inverse secant function. And here, to be honest, I don't have these memorized. These are okay to be referenced. The derivative of the inverse secant function is 1 over absolute value x times the square root of x squared minus 1. All right, so let's ignore the 4x, right? By the chain rule, I'm just going to, everywhere I see an x, I'm going to put a 4x. So the inverse secant function differentiates to 1 over absolute value of 4x times a square root of 4x squared minus 1. Let's double check that we did that right. I've got 1 over what's on the inside of my secant function, or sorry, inverse secant function, and what's on the inside of the inverse secant function squared minus 1. Okay, that looks good. And you can clean this up just a little bit. The absolute value of 4 is just 4. And you can square that. But that's pretty much all you can do. Ooh, wait a minute. I made a mistake because I did not listen to my chain rule. When I took the derivative of the inverse secant function, I should have multiplied by the derivative of the inside of what was inside that secant function. So I got to multiply this by 4. So we actually see a little bit more cancellation. Okay. Let's go over here. If f of x is 2x times arctangent of 2x minus x squared, then we have a product rule. So I'm going to just write out the product rule, and I'm not going to worry about my derivatives until later. I'm just going to remind myself that I have to differentiate things. So I'm going to differentiate the 2x, and I'm going to copy down the arctangent of 2x minus x squared. I'll add to that the copied down version of 2x, and now the derivative of the arctangent part. Okay, and now I can tell myself what derivatives are. So this will give me a 2 arctangent of 2x minus x squared plus a 2x. And now we have to worry about what is the derivative of the arctangent function. So the arctangent function, by going up here, will give 1 over 1 plus x squared. So this would be 1 over 1 plus 2x minus x squared squared. And by the chain rule, I have to multiply by the derivative of the inside of that arctangent function. So we're going to multiply this by a 2 minus a 2x. Okay, this is fine, right? We've taken all of our derivatives, so it's a little bit complicated, but let's try to clean this up. I've got a 2 in front of everything, which leaves us with an arctangent of 2x minus x squared plus a 2x minus 2x squared. So that's me sending this x through here and here, right? This 2 got moved out front. Over a 1 plus 2x minus x squared squared. And I think we'll leave it like that.